All right, so let's talk a little bit about more specifically about the Earth. So we talked a little bit about the different planets. Obviously, there's 8 planets in the solar system, um, and hopefully you remember the acronym. Was it My Mother? No, no, hold on. What was it? I'm trying to remember here. I can look it up. So the acronym. You can tell this is one I don't teach a lot. My very excellent mother just serves us nachos. So my very excellent mother serves us nachos. So my very excellent mother just serves us nachos. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Let's see if we can remember that at some point. So I want to talk about E, or the excellent, or the third planet from the sun, which is the Earth. So there are a number of things that kind of make it interesting. Um, it's the fifth largest planet of the solar system. We only have one moon or one satellite that moves around us, which is our moon. Um, this is actually ironically a leap year, so it's a 166-day year. But it takes the Earth. We talked a little bit about this in the last video. It takes the Earth 365.245 days to go from one place in the sky to another. So that's the distance it takes us to go around the sun. All right, it takes that many days. This is why we have that leap year, because we have to account for that every 0.25 of a day. I'm not really sure who came up with this whole idea of the calendar and what have you like that, but it's pretty amazing that we can predict these things. So the Earth is over 70% water, which is huge for life on Earth. You could not have life if there was no water. Earth is the only planet that we know of in our solar system that has all three states of matter, meaning solid, liquid, and gas. The closer you get to the sun, there's very little to no water, and once you get past Earth, most of the water that's there is going to be in the form of either a solid, most likely not liquid or gas. It's just too cold. The last interesting thing about Earth is that in the center of the Earth, we know that there's a a core. Think of like when you eat like a peach, and there's a pit in the center of the peach. All right, and as you peel the skin of the peach back, it's really thin, and there's the fleshy part of the peach that you eat, and then in the center of the peach, there's a there's a there's a pit in the center. That pit would be equivalent to the core. I think of another fruit that you might think of like that is maybe not a papaya, but a mango. Mango, the same thing, has the skin on the outside that's very thin, which would be like the surface of the Earth, and then there's that thick, meaty section in the center that's called the magma. And in the center, once again, there's some type of pit. We know that pit or that center is made of nickel and iron, and it actually rotates and moves. And the reason we know that is because we have magnets or magnetic fields. When you have a compass in your hand, it always points north, and the reason why is because of the movement of that metal within the center of the Earth. Super cool. And here's a crazy, awful representation of it. So a few facts. Pictures of the Earth, we never actually had pictures of the Earth until the last 100 years. And a lot of that came from, many of the overhead pictures might have started with like hot air balloons, where they take big balloons and fill them with air and attach a camera to it. Excuse me. Send that camera north and actually takes pictures. And then when the balloon would fall, they'd collect the camera and look at the pictures. It wasn't until I want to say one of the Apollo missions. So the Apollo NASA missions were missions where they landed on the moon. Some of the first Apollo missions, they left Earth, went to the moon, and went around the moon. And as they went around the moon, there's this famous picture called Earthrise, and it's the Earth coming up over the horizon from the moon, which is a super cool picture. So obviously, we got a couple of things going on here, some dancing girls, some hula girls. So Earth's rotation, so the fact that it turns and it's tilted, so it's not straight up and down. So if you think of like I don't really have anything to show you with this here, but if I drew a line from the North Pole to the South Pole right through the middle of the Earth, so that round globe, all right, and I held it, it's not straight up and down like this. It actually is tilted. So the tilt actually gives us, it helps with the seasons. So for example, if you're somebody who's from the southern part of the globe, so if you're from I'll use like Brazil for example, or the southern hemisphere, their summers are really really warm because during the summertime they're tilted towards um, the sun. Our winters are cold up here because we're tilted away from the sun. Ironically, our winter we're actually closer. We're actually closer to the sun. Doesn't make any sense, but we're close to the sun, but we're tipped away from the sun, so we don't get the same. We don't get the direct rays. In Brazil in the summertime, not only are you close to the sun, but you're tipped towards the sun. The summers there are super warm. On the reverse, as we move away and we start to spin around the Earth, around the sun, what happens is in our summertime we're tilted towards the sun, so the North America is looking or facing the sun, but we're really far away. So even though we're far away, the direct rays we get from the sun actually cause us to have um, milder summers than they have in the southern hemisphere. Ironically, in the southern hemisphere, really really cold winters. Why? They're really far away and they're tilted away. This is why you see glaciers and things like that down in southern parts of South America, like Chile. Okay, cool. So wind patterns. So there's this thing called the Coriolis effect. The Coriolis effect is that the Earth is not only is it moving around the sun like this, right? It's also spinning on its axis. So it's moving really in two directions. One, it's spinning every day. Once a day it spins. That's why we get 24 hours in our clock or our day. And then in addition to a spin, which is one day, we're also moving around the sun and spinning at the same time. Okay, these things help cause our weather patterns. Sorry for the dumb spinny things. So this normally I would actually give you a worksheet for this. So there's layers to the atmosphere. Exo means outer, so that's the outermost layer. There's 5 layers total. Then there's the thermosphere, which is right below. Then the ionosphere, which is below that. So it goes exo, thermo, ionosphere, mesosphere, stratosphere. Actually, in this case, we have 6 here that we're actually identifying. And the last one is the troposphere. The troposphere is where we live. So this is probably the most important one. The troposphere is where all life on Earth lives. Okay, most of our gases in the atmosphere are actually found in that area, and it only goes from like sea level to about 7 miles. When you think about, I don't know if you've watched the movie, there's a movie about Mount Everest. Mount Everest is the tallest mountain on the planet, somewhere in the neighborhood of 35,000 feet, I believe, which is what 6-7 miles, something like that. When they climb Mount Everest, the further they go from the very bottom to the top of Mount Everest, there's less and less oxygen. So they're forced to carry small tanks, almost like a scuba diver would carry in the water, to allow them to breathe as they get further up. You think about like the Boston Marathon, which unfortunately is not going to happen until the fall. But you think about something like the Boston Marathon. Usually every year, the people that win the marathoners are the Kenyans. And one of the reasons the Kenyans win the marathon so often is because where they live very high above sea level. So instead of living at sea level like we do here in Boston, they live 2 or 3 miles above sea level. There's less oxygen. Because they train there, their body becomes more efficient at burning oxygen to make energy. So kind of a super cool little thing. So when we talk about the Earth itself, there's different parts of the Earth. I use the example of like a peach, or avocado is another good one, or mango. They all have an outer skin, right, which would be the crust. They'd have a mantle. Once again, don't worry about the colors. This is if I had the worksheets, you'd be coloring those were in class. The mantle is like the meaty part, or think of once again like with avocado. There's a skin on the outside. The greenish portion on the inside would be the mantle, and then when you get all the way to the center, you'd have the core. And the core in the Earth has an inner and an outer core. All right. So once again, if we use that example of an avocado or a peach or whatever, any of those types of fruit, the outermost portion, very, very, very thin skin. There's the mantle, which is the next portion inside, and then we have the core. So this is just some facts about the Earth, diameter, that kind of thing. All right. Something you don't really need to know per se. A couple more facts. So the average temperature on the planet range from 0 to 100 degrees. This is an interesting thing. Is the the things that make up our atmosphere. Most of the gas in our atmosphere is nitrogen. Ironically, nitrogen is a gas that we can't use. We breathe it in, we breathe it out, we do nothing with it. 21% of that of the air that we breathe in is oxygen. We need that to go through a process called cellular respiration that allows us to take food and break it down into energy. And then there's a number of other trace elements: CO2, water vapor, things like that. Length of the year, obviously we know it's 365 to 366, and for the most part, our wind runs anywhere from 0 to 50 miles an hour on a regular basis. Some other cool features. I'm always amazed with water. Water's a really cool thing. Water is the only chemical or element, or sorry, I shouldn't say element, chemical or compound on the planet that when it gets colder, it gets bigger. Everything else on the planet, when it gets colder, it shrinks and gets smaller. Water does the opposite. That's why it floats when the water freezes. It's lighter than when it's a liquid or a gas. So, so a couple things with we have these polar ice caps, which we know now are kind of starting to fade away a little bit. Part of that is global warming. It's caused by a number of things. A lot of global warming can be caused by human activity, cars, use of cell phones that use electricity. All these things can all impact how the planet gets warmer. One of our big problems, obviously, is with climate change and global warming, is the fact that there's just too many people. I mean, there's more people currently on the planet than have ever lived and died combined, which is just amazing. There are some people out there that think by the year 2050, geez, which I'll be 75 years old if I make it that long. By the year 2050, they think that there'll be over 11 billion people on the planet. Currently, we only have 8, which is just crazy. Okay, I'm going to stop here. I'm going to send this out to you guys, and hopefully you find this helpful. All right.